Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 2.5, Exponential Form and DeMoivre's Theorem. Now finally I'm going to teach you the exponential form. I'm really excited for this because this is a way more compact way of writing complex forms, especially in the modulus argument form. Also, it is essential, well, kind of essential for you to prove that the multiplication angle theory, and also DeMoivre's is actually really useful for expressing compound angles in simple forms. So basically exponential form is defined as e to the I theta equals to cos theta plus I sine theta. With that, we can actually make things a lot more complicated, because if we take a power of z, let's say if I have z squared, then we get r squared because we do the multiply modulus, then we also technically we should multiply the argument as well. So let's do that. E to the I theta, or multiply or powered to 2, then we can show that by the power law it's equal to e to the I 2 theta. R squared stays, and with that we can basically express this in terms of in the form of r cos theta plus I sine theta, which gives us r squared as your modulus, then cosine of 2 theta plus I sine of 2 theta. This is really helpful, because now we can state the DeMoivre's theorem as of let's see, cosine of theta plus I sine of theta, all to the power of n, is equal to cosine of n theta plus I sine of n theta. This whole thing is called the DeMoivre's theorem, and this basically proves, because if you take 2 e to the power, say e I to the theta, multiply that by e I to the I don't know, sigma, why not? E I to theta times e I to the sigma will give you e I to the theta plus sigma from just power law, and we all know that from basic GCSE anyway. With that, we have now concluded that the angle do indeed add together, and so what I've said back then when we first learned how to multiply applies. So that works, which is good. What about this? DeMoivre's are useful because you can express compound angles in terms of the simple trig. So let's have a look at how to do this. Normally, when you are stuck with cosine to the n theta or nx, whatever, you're kind of stuck there because you can't do anything. But if you express this whole thing as a complex number, then you could do something. Say this is basically the real part of that e is unnecessary, but real part of a certain z, which is cosine of 3x plus I sine of 3x. With that, we know from DeMoivre's that we can turn that into cosine x plus I sine x all to the power 3. This is just write down DeMoivre's. And that would imply that you are using the law and not just kind of doing something weird with the math. With that now, we can simply expand using binomial expansion, which should give us cosine cubed x add cosine squared x I sine x. Remember the coefficient and add 3 cosine x I squared sine squared x, then add finally I cubed sine cubed x. This is the expression of this whole thing. And now remember that the solution that we're looking for is the real part of this complex number. And this complex number is the same as this massive expression, which means that if we take the real part of this whole thing, we should get cos of 3x. So the real part, this is a real part, this is not, this is a real part, this is not. And so we take those two together and we get cosine cubed of x add minus 1 because I squared times 3 cosine x sine squared x. So now we want to express this whole thing in terms of just cosine, but we have a sine squared. One of the things that you know is that sine squared is 1 take cos squared for any x because of just trig identity. So we can sub this in and we shall get cos cubed x take 3 lots of cosine x take cosine cubed x. With that we expand to get 1 take plus, so 1 plus 3 is 4 cosine cubed x take 3 cos x. And that would be the solution, or the cos 3x in terms of cos x. This type of question is very, very likely to be present in your final exam, which if you can nail this, it's 3 marks. It's actually really quite simple to do and it doesn't take much practice. It's literally just straight algebra. So do learn this, it's useful. So make sure you're able to separate the real part and the imaginary part for any complex number, because if you can't use this, then the DeMoivres are essentially kind of not very useful. But if you can do the real part and imaginary part, you can do a lot of physics, you can do a lot of just straight math. And for the purpose of A-level, knowing this DeMoivre's is really good, because you essentially you just get 5 free marks for just remembering how this power thing works. And it's not even complex algebra, and so it's really, really useful and nice to have. So now that you've seen DeMoivre's, you can attempt these 2 questions. For the question number 2, I think it might not be that obvious as to what you should do, but it's not that difficult. If you, I'll give you a tip, express a complex number, a unit complex number, with the modulus argument form, and then you can rearrange to get sine and cos. But for now, I'm gonna give you 5 seconds to digest this, and in 5 seconds I'm gonna give you the answer. So in 5, 4, 3, 2, 1, and there you go. Question 1 is again straight algebra. The power kind of sine 5 and cos 5x are very common in the A-level exams, at least in the previous spec. So I will not be surprised that they will throw something in this order of magnitude at you during the real thing. It can be either the imaginary part, which is the sine part, or the complex, or the real part, which is the cosines. They essentially have the same kind of shape or form. I think for cosine there's like an 11 somewhere, or it might just be me thinking, like, it's experience. You do see them a lot. And for sine and cosine, remember, you are allowed to just pluck this out of thin air when you do trigonometries. So sometimes when you're stuck doing some form of algebra, I don't know, differentiating or maybe integrating with some crazy things, it might be useful to turn it into complex form. So with that said, that's all for this video. I hope you've learned something, and if you did, then do tell me in the comment section below, or if you have any questions, do leave it in the comments as well. For now, I'll see you on my next one.